Here we're troubleshooting an orthokeratology case. This patient initially had complaints about glare and reduced visual acuity after lens dispensing. And you had already made some changes to the lens, steepening the periphery to get slightly better centration of the treatment zone. The lens looks like it still fits a little bit loose in the vertical meridian, but you're getting excellent centration right over the pupil. I think that, along with some neuroadaptation, is probably taking care of the complaint of glare, but the issue of the unsatisfactory visual acuity still remains. Looking at the pre-wear topography, it looks like the corneal toricity extends over a pretty broad range of the cornea, and I believe the OR after dispensing shows there's still a diopter and 3/4 of cylinder that is not corrected. So due to the amount of cylinder we're trying to correct, as well as the distribution, the wider distribution of the toricity across the cornea, I think this would be a good time to go ahead and pull out that big gun of the oval optic zone or oval treatment zone and see if we can reduce some of this toricity that's causing the patient's complaint. So I'm going to bring up the lenses and show you how that can be done. Here we have two windows of the same lens right now. This is the most recent design for the right eye, and it's at an 11.1 millimeter diameter, which I think is an excellent move. He originally started with a 10.8, and on this patient's cornea, which was around 11.4, I think 11.1, 11.2 would be a good size for good centration, and that's what you have achieved so far. So to create the oval zone, what we want to do is increase our treatment in the vertical meridian here. Right now we're at a 1.66, and we have 1.75 diopters uncorrected with the rule. So we want this power to be closer to 3.4. And first thing I'm going to do is create the oval optic zone. So we're doing this in 50% since we only want to do this in the vertical meridian. And I'm going to bring this from 6.5 down to 5.9. Similarly, I'm going to bring the IC from 7.1 to 6.5. I'm only changing the size of the zones. I'm not changing any vertical displacement of the control points at this point. Because you're designing in freeform, we need to go down to the bottom and do the same thing. Still in 50%, we're going from 6.5 to 5.9. Seven one to 6.5. Here in the fluorescein, you can now see that you do have that oval optic zone. In the 180 meridian, our power has not changed. We're still at a demand of 1.64, or a power of 1.64. Vertically, initially we were at 1.66. Just by reducing the size of the zone vertically, we've already increased the power to 2.6. Our goal was 3.4, so I am going to increase that still in 50% mode until we're at 3.4. So I'm just clicking up. And 3.4. I'm going to go down to the bottom and do the same thing. .44. I'm going to go with 337. Here on the back surface, curvature, you can see there's toricity now. And if we move along the different meridians, you can see where the treatment zone swings in vertically and out horizontally. So it looks like we're all set for the right eye. I'm going to pause the video and get the left eye set up. Here are the pre and post wear maps for the left eye. Again, you can see the corneal toricity, about 80 degrees, covering up, again, a fairly broad area of the cornea. This side, the refractive cylinder was only about a diopter. However, after lens dispensing, 3/4 was still remaining. So even though we're not correcting a huge quantity of toricity, a broader area, and the fact that not much of it went away with the regular lens, I would still lean towards doing an optic zone that's oval for this patient. On the post-wear map, there is a little bit of looseness again in the vertical meridian. The treatment zone is shifted slightly superiorly, perhaps steepening the periphery could drop this lens down a little bit, maybe give you slightly better centration. Although if the patient isn't really complaining of glare anymore, I'm not sure I'd really do that. I think what I'll do is just for demonstration purposes, show you how I would steepen the periphery that way. Not necessarily as an indication that you should do it, but just in case you wanted to. So let me pause again and I'll bring up the lenses. So here again we have two windows of the same lens. This is the most recent design for the left eye. It's 11.1 diameter, which I think would be great for this cornea. You are designing in freeform mode. So all the changes we're making are going to be in 50%. But because we're in freeform, we need to do it to both the top and the bottom half of the lens. So again, just for demonstration purposes, not necessarily saying this is what I would do, but in case you wanted to steepen the vertical meridian of the lens to see we get that lens to drop a little bit. On the cornea right now, we're at about 5.9 microns of supposedly central clearance, and to drop down the periphery, just click down here. Now we're at 10.4. I usually try to go about 5 microns at a time. If we vault the cornea too much all at once, we sometimes get unexpected treatment results, even inducing central islands, which generally makes the patient quite unhappy because they can end up being more myopic than when they started. So I think 10.4 is a good amount there. I'm going to go to the lower meridian. And bring that down. We're again 10.4, and we initially started at 5.9, so about 4.5 microns. Next we're going to do is create that oval optic zone. So I'll just start with the lower meridian here. By the way, we're at 1.67. If we want 3/4 more, that would put us at what would that be? 3.42 or so. I'm sorry, that would be 2.42. So that would be our target. I'm going to bring this in first from 6.5 to 5.9. Seven 1 to 6.5. Again, we're 50%. We're going to do the same thing at the top. 5.9. And 6.5. Okay. By bringing the zone in, you can see that we've already overshot the amount of extra power that we wanted to generate in that meridian. So um, in this case, this is why with 3/4 diopter of residual cylinder, I normally wouldn't do an oval zone. It normally wouldn't call for it, but in this case, um, we're going to try it. So I'm going to bring this down to the 242 we originally wanted, and this one, clicking down also to reduce the demand, and right about there. So again, you can see the ovalness of the zone. Not quite as much back surface toricity as we saw on the right eye, but we were correcting a lot more cylinder there. And if we go through the different meridians, just to double check, comparing to the initial lens, you can see we're still maintaining the same demand horizontally, but vertically, we've added about 3/4 of a diopter more treatment. So hopefully this does work out well for your patient, and thanks for watching.